Hey guys, what's happening? Welcome back to Your Forest. I'm Matthew Christoph, and today we're talking wood. Talking all kinds of wood. Why do you use wood? Hardwood, softwood, tall wood, wide wood, all the wood. Wood. Yeah, it's going to be good. Just kind of getting into explaining why wood is the ultimate use for building and for a building block for anything, really. Why it's the most sustainable, all that kind of stuff. And I brought on Rory Koska, who is with Woodworks, and Woodworks is an organization. They're tied in with the Canadian Wood Council, and they're just trying to promote the use of wood in all kinds of different aspects, right? So mostly for building. But yeah, we talk about a bunch of different types of new technologies that have recently come up in the last few years regarding building with wood. So cross-laminated timber, glulam, laminated veneer lumber, yeah, all that kind of stuff. Just talking about building, trying to build these tall buildings. So you guys might have heard of the building in Vancouver that was 18 stories tall, 17 and a half, I think he said, something like that. Yeah, that has to do with using glulam and CLT and stuff like that. And, yeah, so we got into how we can build taller with wood, why it's a good thing, why it's fire resistant. And we talked a little bit about where things might end up, some of the policy changes that had to happen. But yeah, it was really, really good. And I think it covered it well. And I think we're going to see more and more use of wood products in the future. It only makes sense, if you can get similar specs to steel in some respects, then why wouldn't you use the sustainable product rather than using something that you have to mine and smelt and use up a bunch of resources to create, right? So yeah, we're talking all about that kind of stuff, all about wood. It was really, really good. You guys will like it. As far as sponsors go, we're just talking, same three sponsors as always. Greenlink Forestry, resource inventory analysis, basically taking photos and LiDAR using remote sensing to, get a good picture of the forest so that, managers know what they got out there. And also the Forest Resource Improvement Association of Alberta. I couldn't do this without them. Thanks for everything you guys do for me. Appreciate it. And also Damaged Timber. Damaged Timber is an apparel company out of Edmonton. They are trying to support environmental sciences through the sale of their clothing. They're trying to create a scholarship program for people going to environmental sciences, taking 10% of the sale of their clothing and putting it towards that. Yeah, they got awesome, really cool hats and t-shirts and stuff and hoodies and toques and that. And it's really, really cool. I like it a lot. If you guys want to support something like that, go to damagedtimber.com, put in Your Forest 10 at checkout and you can get 10% off. And that's off all their sales and all kinds of stuff like that. So yeah, without any further ado, Rory and I got straight into it talking about what Woodworks is, what his role is, and, and then into the wood products. So, thanks a lot for listening, guys. Don't forget to rate and review when you're done listening. I really appreciate it. It helps me out a lot. It helps me build it up into the iTunes category so more people run into it, more people see it, right? So awesome. Thanks a lot, guys. Hope you guys like it. Yeah, so you said your position is
I'm the director of the Alberta program.
Okay, so Canada-wide, how long has Woodworks been going on?
15 plus years in total across Canada. Yeah.
Oh, okay.
Yeah.
And so what is Woodworks? What's the purpose of it? Like, how did it start?
Yeah, so Woodworks is it's a program of the Canadian Wood Council.
Okay.
So we should probably start with the Wood Council is first. I don't know if you're familiar with the Canadian Wood Council or CWC.
Hear it all the time, but I had no idea what it is.
So they're made up of the associations across the province, the Lumber Association. So here in Alberta, the Alberta Forest Products Association, Kofi out of BC. So all of those members pay into that provincial regulator or the provincial association with AFPA here.
Yeah.
And then they're all made up of the Canadian Wood Council. And the Canadian Wood Council obviously represents them.
Okay.
And then what we're doing more on the woodwork side, and what I deal with at the CWC is more codes and regulation.
Oh, okay.
So they're the ones that affect the codes, the National Building Code, trying to help get wood put into the building code,
right,
and make it easier for building with wood.
Gotcha.
So Woodworks itself, I said we're sort of the promotional and education side of the Wood Council. So we'll take that information that's the research and the information that's been done at the CWC and through NRCan, and we'll put that forward to designers, so architects, engineers, and we'll help them try to help them understand how to build with wood,
Right.
if they need that assistance, and then try to help them go beyond what the code is allowing them right now,
Right.
and look to the future and see where they can go.
Yeah.
And right now that's taller wood buildings.
Taller wood. Yeah. Well, I guess we should start maybe just talking about why wood. Like I think a lot of people they don't even think about why you would use wood over like steel or brick or what concrete or whatever, right? Because I think they just think, oh well, this is strong and this is sturdy, but they don't think about the the unsustainability of some of those other products versus wood, right? So maybe we should get into why using more wood on like day-to-day basis, especially with building and stuff like that, why that's a a net positive for society.
Yeah. Well,
and the environment and the world and everything, right?
Yeah. So a colleague of mine kind of came up with a list, and when we're asked that, why build with wood, actually our answer is the question back is why not? So
that'll work.
It's a material that's grown. We can harvest it as a crop. We can continue to reuse it. It sequesters carbon.
Yeah.
It's the greenest building material. One of the greenest building material there is. So why not use it?
Yeah. I always say that. I remember my dad growing up, he was telling me that he's like, wood is one of the only truly sustainable resources that we have for building material on the planet.
Yeah.
Whether it's like just a simple, just the wood fiber itself, right? Yeah. Whether it's for making a cup to drink your coffee out of, to making a house, to making whatever, right?
Yeah.
And it's, I struggle can you think of anything else that is more sustainable? Like I think people talk about hemp and stuff like that. And I've said this a couple times, but hemp, again, it's a crop. It depends on fertilizer and you deplete the soils and so it requires inputs. Yeah. Whereas trees, in the way that we do it in Canada and the United States and Europe and stuff like that, is totally sustainable and self-reliant.
Right.
So, yeah, I can't think of.
Yeah, you could use like maybe some rammed earth as well. But really,
rammed earth.
Yeah.
Oh, okay.
Yeah. So taking dirt and the earth and kind of compressing it,
right,
and making you can make walls and systems out of it as well. So
so do they do that? Yeah. Like, is that a common practice in like the?
It's not very common, but you see it. Some
never heard of that.
being used, and then straw bale as well.
Right.
But really, our perspective is the best building material, the most environmentally friendly building material is using wood.
Yeah.
It's grown. We grow it. It grows by itself. It continues to grow.
Yeah.
And as you mentioned and said, we're the most sustainable forest practice around. And why not utilize it? We get questioned quite often about, we're going to deplete the forests and, is it certified? But all of our forestry is certified between those certifying bodies, and we are considered one of the most sustainable forestry practices in the world. So why not use it?
Yeah. I think we're like a lot of countries look towards replicating our model of certification and regulation because it is so it's held to a higher standard, right? Yeah. In North America in general, and like I remember I had Dalbar Hudek on.
Oh, yeah.
Dalbar?
Yeah, I know him quite well.
And he was talking about he was breaking down kind of the differences in like carbon usage and stuff like that, and like use of water and like all the resources that go into build like to certain materials like steel and brick and all that kind of stuff.
Sure.
And it was something like 300 times or 300% more than wood, right?
Yeah.
Just like the pure resources that go into it, and not to say that they're not replenishable.
Yeah.
Right. So I think that's a big thing that people just kind of think, like you should people like to use steel and stuff because it's stronger, but I guess we'll get into that kind of stuff. Yeah. One big thing still sticking on just kind of why we use wood is, like people were talking about wood is lighter. They say it's advantageous. That their strength to weight ratio is advantageous compared to steel and stuff like that. Can you speak to that a little bit? I don't really understand what's going on there.
Yeah, and it depends on the way it's used as well.
Right.
Wood's really good in compression. So using it there, you want to use the material at where it's going to be put into an advantageous role.
So you say compression. What do you mean by that?
Like when it's being pushed together, right?
So like that, like the ends of a 2x4 are being
Right.
pressed
Yeah.
towards each other. So
Exactly.
not necessarily pressed
Yeah.
down on a 2x4, but down straight from the top to the
Right.
bottom. Okay,
Yeah.
gotcha.
Yeah, not
Okay.
in tension where you're pulling it.
Pulling it is tension. Compression is just from end to end.
Right.
And then what would it be pushing like down on like a, so you have a 2x4 laying horizontal, pushing down
Yeah,
on the
that would
sides.
be compression perpendicular to grain,
Oh, okay.
right? So your grain of your wood, if it's laying down, is going to be kind of horizontal to the plane, right? But
Yeah.
then if you have weight coming down perpendicular to that, then that's
Right.
compression to grain, which it's not. That's where you'll start crushing it.
Right.
So if you have it vertically,
Right.
where your grain is vertical,
Yeah, that's
then
the best.
That's the best.
Gotcha.
But,
Okay. Makes
yeah,
sense.
no, it's lighter.
Yeah.
We've seen some of the documents and some of the research that's been done on some of these taller buildings that's been going up.
Yeah.
And the weight of the building is a quarter of the weight
Okay.
because you've removed a lot of the heavier material
Right.
out of it. So now you start putting up a building of size,
Mhm.
you're reducing the weight. Now it also reduces the amount of concrete that's required in the foundation, the amount of steel that's required
Yeah.
within that concrete to keep it strong and going. So
Right.
yeah, it's
So, like, why would being lighter why would that be a benefit? Like,
Well,
you know what I mean? It's not
yeah.
like it's moving. Like, I guess it's moving a bit in the wind. Is
Yeah.
that kind of the thought process there? Is
well, yeah, it allows it to move a little bit more, but
Yeah.
wood itself can do that
Right.
on its own. But being lighter again, I'll just reiterate the foundation is going to be lighter.
right?
So you're using less material now in
Okay,
the
so just-
foundation and such, as well as the construction of the building as well.
Right.
So now you can use smaller equipment,
Yeah.
lighter equipment on site. You don't have to have such big cranes hauling this material up.
Okay.
You can use lighter cranes. You can use less people on site as well to move it around. So
Okay.
Yeah.
Okay. And I guess someone was telling me, I don't know if this is true or not, but it might be better for something like weather, for wind and stuff.
Mhm.
Like it might have more movement. Like, I don't know, is that true or is
well,
it
that's probably
relative?
it'd probably be more considered in an earthquake zone.
Okay.
Which in Alberta we're not really too worried about, but
Yeah.
if you're looking, Vancouver, BC, they are in a seismic zone,
Right.
and having a material that can withstand some movement,
Mhm.
can bend a little bit versus being very rigid. It's just better. It'll allow that building to move and then come back to its original position
Oh, okay.
without breaking too much stuff.
Right.
Where you have something that's very rigid, and as soon as you start moving it, it cracks. Then now you have failures.
Right. Yeah. But
Yeah.
so is wood, like, does it compare to steel and stuff like that when you're talking about, do you know the comparison?
I don't know the comparison. So
Oh, okay.
I can't really speak to that. No.
But I guess we're moving towards understanding that a little bit more, right?
Yeah,
So,
exactly.
so I guess, so in the past, specs for like purely wood buildings, as far as or whatever, more or less purely wood buildings was what? Because like now we're moving into these like 3, 4, and then like 10 to 12 story buildings, right?
Right.
So what was the technological breakthrough? Like what happened that allowed us to build taller?
A couple things. So originally here in Alberta, we could only go up to 4 stories or 9 meters.
Okay.
Which was pretty tough to get a 4-story building in underneath unless you had 8-foot ceilings. Everybody wanted taller, wanted 9-foot ceilings, 10-foot ceilings. So that put buildings up over top of that 9-meter mark. So, but we were still able to do 3 to 4 story in light frame construction.
Okay.
Then in Europe, they started using this new material called cross-laminated timber, which was a lot different than our light frame construction, 2x4s, 2x6s, spaced out on certain on centers. This is all laminated together, making big panels.
Right.
Almost like a comparison people use as jumbo plywood.
Right.
So you're making panels, 8-10 feet wide, 40-60 feet in length or less, depending on what's required.
Yeah.
Laminating them together between 3 and 9 laminations thick. So you're looking at 4.5 inches thick up to like a foot thick.
Oh, okay.
For these panels of just pure wood mass.
And what's just so for some people don't know my understanding is you're taking basically the 2x4s and 2x6s and gluing them together to make these panels.
Yeah.
Right.
But you're gluing them side to side versus face to face. So you're gluing them together. Each row is side to side, so on the inch and a half, if you will,
Right.
plane, not the
shorter
face.
side.
Exactly,
Right.
the shorter side.
Gotcha.
So you do one lamination that way, and then you turn 90 degrees, and you fill another lamination across that way, and then a third coming back. So that's where the cross lamination comes in. So you have 3 laminations minimum that way, up to 9, depending on what the load is required to carry. And
so the same idea with plywood, just using lumber instead of the veneer. Yeah. Okay.
Exactly. So when they started using that in Europe, they realized that they could go a lot taller.
Yeah.
So they really started to boom there. There was a building that was done there by a gentleman, Andrew Waugh, and the architecture firm is Waugh Thistleton. So he did this one called Murray Grove, and it was a 9-story wood building. So it was actually 8 on 1. So the main floor is concrete. And he kind of broke the mold and got a lot of attention.
Right.
We brought him out to Alberta a couple times to speak on this building as well. And that's the one that kind of lit the fuse, if you will. And all of a sudden, everybody started looking at this and realized, well, why can't we do this?
Yeah.
They're doing it. Why can't we do it here? So,
right.
What
year is this?
Oh, I want to say about
roughly
6 or 7 years, 6 years ago, probably.
Okay,
5
so
or 6
recently.
years ago. Quite recently.
Recently,
yeah.
okay.
Yeah. Then a boom's kind of taken off on it.
Yeah.
And so then North America was looked at. The people from North America looked at it and said, well, why can't we do it here? And then people started looking at the use of that material. A couple plants opened up in North America, servicing some smaller buildings.
Mm-hmm.
And then we had a building in BC called Brock Commons,
right,
at the university at UBC. And they were able to do an 18-story, so a 17 on 1.
That was 17.
Yeah, 17
Jesus.
wood on 1 concrete.
So that was all using so it was all using CLT as the what you call it,
so it was it was glulam and paralam post and beam construction.
Okay.
So the columns and beams.
Yeah.
And then the CLT was used as the floor plates.
Oh, okay, I see.
Yeah.
Okay, so the glulam and what was the other one you said?
Paralam.
Paralam. So could you explain those real quick?
So glulam is basically 2x6, 2x4, 2x8 kind of glued together to create a beam or a column.
Right.
And those are face to face.
Right.
And then paralam is a different type of engineered wood product. It's kind of used from pieces of wood that has been stripped down and then glued up back together. And a very, very high capacity engineered wood product. So they use that in a couple places on the lower floor just to keep the dimensions of the columns a little bit smaller.
Oh, okay.
And then the rest of the building went up with glulam.
Okay, so the glulam and stuff is what's used as not the struts, but as the like vertical standing.
Yeah,
wood.
vertical and horizontal.
Okay,
right.
And then you just had the CLT as like the floors. You said.
Yeah, then the CLT plates would span.
Gotcha.
Across.
Oh, okay. That's crazy. So they got to 17 stories that way.
17 stories.
That's bananas.
Yeah.
That's awesome. That's cool. Yeah. So, that was in Vancouver, you said?
That's it. Yeah. The University of British Columbia.
University of British Columbia. Oh, okay. Okay. Interesting.
Yeah.
That's crazy. So that must have been like crazy to try and get the specs passed to allow them to do that, eh?
Yeah. There was, so what ended up happening was NRCan, put out a call for proposals, an expression of interest from across Canada looking for, anybody that would be interested in doing a tall wood building.
Right. And NRCans, that's the government, right?
Yeah.
That's
Yeah. They're a program through the federal government.
Right.
And they, UBC, was interested. They needed, some student housing.
Right.
So they were interested and, they put together a proposal. They had to do a 2-story mock-up of the building. There were some other things they wanted to do. Obviously, fire is always a concern when you have wood being used. So, combustible construction. So they went from 2 layers of drywall. That's the norm to be used. They asked for 3 layers.
Right.
They kind of signed off on it. It was outside the building code, so they needed to do an alternative solution for it.
Right.
But UBC was satisfied with that, and they signed off on it, and up it went.
That's sweet. So, so is that going to become more common, do you think, like in that Vancouver area now that's, you know what I mean, that seal's been broken there? Do you think you start seeing like more residential stuff going up that way?
Most certainly. I see it's going to become the norm across.
That's cool.
Across Canada, across the world, really.
So they've started to change policy to allow that kind of stuff. And because we understand what it can do now. So that we've kind of got that basis down to get to 17 stories. Anyways.
Exactly.
Gotcha.
Yeah. It's still not in the National Building Code yet.
Right.
The National Building Code is in every 5-year cycle.
Okay.
So we're working, the Canadian Wood Council is working on implementing some more pieces of the use of this type of material.
Yeah.
This type of system into the building code coming up. So
Right.
it'll happen.
Yeah.
We'll see it happen, but we're seeing it used more and more all the time. There was another expression for interest that came out in the fall, and multiple more buildings that had applied to it, and we'll see more buildings across Canada coming up.
That's cool.
That
So you're talking about like the fire. I think that's something that people, like even myself, I was like, well, yeah, that is interesting. I never thought about that till after someone brought it up, was the fire aspect. That you'd think, okay, and now it's going from something that's steel to wood.
Yeah.
You'd expect it to be more flammable and therefore more dangerous, right?
Yeah.
So, but apparently that's not exactly the case.
Not exactly the case, no.
Yeah.
When you start, we're used to, especially here in North America, we're used to light frame construction. So 2x4s or 2x6s on 2 feet on center, 16 inches on center.
Yeah.
And they're small pieces of wood. Easy to set on fire, and
Right.
easy for that fire to continue growing.
Basically, just because of the surface area to
Right.
volume ratio, there's more surface area than volume, so it's easy to catch. Yeah,
you think about going camping. We've all been camping. We've all started some fires, and what do you start with? Smaller pieces of wood. You start start kindling, and it gets a lot of air in there.
Yeah.
But if you drop a big log on, it's very hard to start that fire or to keep that fire going.
You got the old gasoline.
That's right. Exactly. So what ends up happening is with these larger cross sections of wood being used, if it's glulam or CLT or engineered wood product, the bigger sections, a fire will start. And yes, it'll catch on the outside. But what ends up happening is that it creates a layer of char.
Okay.
Same thing as that happens in when we make a fire and that log chars up, and it's hard for that fire to continue going. So
right.
Now it doesn't have the material to keep burning, so
right.
it puts itself out.
Yeah.
I want to go back to that the first project that kind of opened the door for this at Murray Grove. They had to do some testing.
Yeah.
And they set up a room. And they brought the fire department in, not a full-scale test, but very close.
Okay.
They started a fire in the corner, and the fire put itself out.
Oh, really?
So then they started another fire, and they opened a window, and the fire put itself out.
Yeah.
Then they started it again, opened the window, opened a door, and continued down this road until they could get a fire going. And they never were really able to get anything of significance going. So the fire department finally walked away and said, "Okay,
nice.
We're okay with this.
That's sweet.
We understand what's happening." So yeah.
So there's the glue that you use, is it fire resistant in any way, or is it? It is. Yeah. Okay. So that probably helps a lot too.
Yeah. Exactly.
Okay.
Exactly.
So it's basically just the wood that can burn. So the glue also works as a fire retardant somehow. Yeah.
Yeah.
Oh,
yeah.
okay.
It's not that it's a fire retardant. It doesn't catch fire. It doesn't melt away or anything like that.
As easily. Yeah.
Yeah. So they did some testing when they were bringing this to North America, and the first set of glue that they were planning on using, they did some testing. They put panels in these big ovens that they do to start fire, and they failed.
Yeah.
So they went back and said, well, it's the glue that's failing on these. So the panel started coming apart due to heat.
Right.
And so they changed the glue and went back and retested, and everything was fine after that. They've had some of these panels, 7 layers, 9 layers. They've been in these ovens for 4 hours.
Right.
And they're still holding their integrity.
Wow.
So
yeah, that's amazing. And you would hope that a building on fire wouldn't burn for 4 hours straight at a high intensity heat at like 2,000 degrees or whatever, right? That's crazy. It makes sense, I guess, right? Because it's not like you think about a campfire, and the only reason the campfire stays lit is because you've got this giant pile of red embers and ash directly underneath the wood, feeding it constantly heat, right? Whereas a building, there's a lot of empty space. It's mostly empty space. So you're not going to have that congregation of heat and embers that can continue to feed and immediately lick the wood just above it, right?
Exactly.
So yeah, it makes sense. Yeah. So how is it compared to steel and other, other stuff? Do you know?
Depending on the steel, like light gauge steel that we see, most office buildings and such framed out now, they will not last as long.
Steel won't last as long?
No, okay. It won't catch fire, but it just loses its strength and its integrity.
It just kind of softens up and
Structural steel, the bigger stuff like the big red stuff and that, it'll last a while. It'll last quite a while as well.
Right.
And I don't want to be focused, or I don't want to be come across as putting down other material, because we need to use steel and we need to use concrete.
Yeah.
But we also need to use wood. So
yeah,
I don't want to come across as putting down other material, because we do need it, and we need it in the right times at the right locations. So
right.
I think there's a big playground, a big sandbox, if you will, for construction. And I think everybody has their spot in there, and we can utilize it.
Well, it's the same as anything in society, right? Like you think about even like fossil fuels and stuff, right? Like, sure, it'd be awesome if we could all be off fossil fuels and be using green energy, but we haven't figured that out yet. So until then, we need to it's a slow movement on society, right? And like with wood, it's, like we would like to use as much wood as possible. However, there are time and places where, you need to use other materials. It's not,
Exactly. And Brock Commons, they have a concrete elevator shaft. And stairwell, so which they wanted to utilize. So
that's the one in Vancouver.
Vancouver, yeah. And if we start seeing even these bigger buildings, we're going to see the what we call a hybrid construction.
Yeah,
there's going to be some steel used in there. There's going to be some concrete. There's going to be some wood.
Yeah,
just as long as they're used mindfully in the right times,
in
the right places. So.
Oh, and wood's beautiful. It's the best looking one, right? Like you can't deny that wood looks incredible no matter where it is, right?
Exactly.
So it's in my opinion, it's a no brainer. Kind of makes sense, especially because now we've got this technology moving forward that's helping out.
Yeah.
Do you see any other like wood products that are kind of like, do you have your eye on anything that might be changing the game again?
Sure. So there's CLT, most certainly, but back to glulam.
Yeah.
So what we're calling the acronym of GLT. There's so many acronyms. GLT, LSL. Throw in BLT if you want to.
Dude, that's one of the biggest problems I have with the podcast is trying to now get away from the jargon, right? I'm like, stop with the jargon. Nobody knows what that is.
Exactly.
Yeah.
But people have reinvented glulam to, instead of using it just as a beam, but now creating it and using it on its side and using it as a panel system.
Right.
So for floor panels as well. It can be utilized that way, or nail lam, which we used to see.
Nail lam?
Nail lam, yeah. So
I've never heard of that.
Warehouses,
Okay.
a little older than that, 100 years ago, 80 years ago,
Yeah.
when we were constructing these warehouses. Like even here in Edmonton, we don't have a lot.
Yeah.
There's an old storage facility over by the downtown theaters, over by Eaton Center or whatever it's called now.
Okay.
Rogers Place. There's an old storage place there, and I can't even remember how many stories. I think it's four stories tall.
Like by Mercer's Tavern and stuff?
Just south of Mercer's Tavern.
There's
storage building.
Yeah.
So that's a full wood building.
Yeah.
So it was done in heavy timber, so solid sawn timber as post and beam construction.
Yeah.
But the floors are laid out as nail laminated. So they take 2x6s, put one on edge, nail the next one to it.
Oh, okay.
So forth and so forth. So 2x6, 2x. And actually, Mercer's is built that way.
Oh, I see. So it's like not laminated like with the glue, it's laminated with nails. I understand. Okay.
Yeah.
I was
so
like, what?
Mechanically
Gotcha.
fast.
It's interesting that's still called laminated that way, but I guess it's lamination. Okay, interesting. Yeah, I would. Okay.
Yeah, so
cool.
we're seeing a resurgence of those kinds of buildings as well. So, you can nail it together. Now, if you're nailing it together, you don't need to pay a special manufacturer to do it. You can kind of set up a jig and have framers put it together.
Right.
Guys on site to put it together.
Gotcha.
Takes a little longer if you glue it all up and you just buy these panels that are 2 feet wide or 4 feet wide.
Yeah.
And whatever length you require.
Yeah.
And they plop them down pretty quick.
Yeah.
You can cover a lot of square footage fast.
I love all that new stuff. It looks so cool. I remember I went to what would have been? It would have been a while back. Would have been probably 10 years ago now. I was in Sundry's mill, and they have the LVL, laminated veneer lumber, right? And that's so for people that don't know what that is, the same thing. It's basically just plywood but thicker, and they continually are overlapping it to make it like infinitely long if you want to, right? So what's the application of that kind of stuff? What I've seen it in is for example those large large buildings where you want to have a 50 or whatever 30 meter long beam, cross beam or whatever, right? So, and you can make them curved, you can make them straight, you can make them, it's beautiful. It looks really cool.
Yeah. Most of the panel sides, so nail lamination or glulam used as a panel or CLT, is used as a floor plate or a roof plate.
Gotcha.
So you'll have some additional structure underneath it, and then those will sit down to create your whole floor system.
Okay.
And they CNC out the window openings if it's used as a wall, or stairwell openings, your plumbing openings and such. So we were working with, trying to remember the name of the motel chain, Budget Hotel thing. It's the cowboy hat.
Chain. Yeah, I think that's Budget. Yeah.
So they put up a building and they put together a whole floor system, the whole floor of the hotel in a day.
Oh, really?
Just laid it down. Truck would pull up. They would just take panels off with a picker, lay it down, and then they would frame their walls in afterwards.
Gotcha.
It would take them about a week to frame the walls in.
Yeah.
And then the next trucks would come in and put down the place for the floor system. So
yeah, it's cool because you can continue, like you can basically make it as long as you want, right? Like it just goes to infinitum if you want it to be. Like it just keeps going as big as the mill is, or you start pushing it out the front door, I guess, and keep going.
Yeah, exactly.
Yeah.
Exactly.
So
as long as you can ship it, they can pretty much build it that long.
So do you know how long have they used it structurally that it's held up, like LVL and glulam, as far as like for like a strut or something?
Glulam? Well, geez, go to any old hockey arena throughout the prairies.
Yeah,
you still have those buildings that are using glulam.
And those are, what would they be? They'd be like 50 meters or 60 meters long, I guess.
Yeah, getting there.
It's long. Yeah,
you bet.
For those who don't know, a meter is roughly 3 feet.
Exactly. They're used old potash facilities. They use glulam all the time because of the corrosiveness of potash.
Okay.
They have a hard time using metal because it rusts out really quickly.
Gotcha.
So they go to wood, and some of those arches that they've provided there are 130 feet. No, a little bit bigger. About 5 or 6 houses long.
Wow. Yeah.
I remember some of the pictures I saw.
That's awesome.
Just massive.
Yeah.
And, we're seeing a resurgence in a lot of the use of that. We have, here in Edmonton itself, the Meadows Rec Center, the roof system was all done with glulam.
Oh, okay.
Some steel tension in there as well.
Yep.
So over top of hockey arenas, over top of the pools, through libraries, we're seeing down in Calgary. They just finish 2 rec centers there. Rocky Ridge, which is the largest wood roof right now.
Nice.
In North America. They used glulam there to warm up the space and such. Just an incredibly looking building.
Looks so cool.
Amazing.
That's what I'm saying. It looks awesome, and the engineering. We figured out the engineering to the point now where it's like, it's working out. There's no reason not to use it now, and it's the most sustainable. All that good stuff. Mm-hmm. Yeah, it's wild. I was reading up. I don't know if you know anything about this, but just in April, I think it was, or came out, or March, that densified wood. You heard of that?
No.
Oh, it was like, I was reading about it in Japan, I think it was. They created this wood they basically take normal wood, like a normal 2x4 or whatever, and compress it, like break down the cells so that there's no space between the cells anymore. They just, so it basically becomes, what did I write down? It said, it's like a tenth of the width of a normal board, but 10 times as strong because there's no empty space. And and they're claiming, like, Japan was saying that they want to make a 350 meter tall building by 20.
Wow.
I didn't write it down. They said like 2030 or something like that. We're going to have a 350 meter tall wood building. I'm like, we're using this densified wood. Yeah. Right. And I'm like, if that's real, and the densified wood thing is, like, I can't even imagine how much of a game changer that is. Like, that's
incredible.
What else did they do? Sorry. Yeah. I missed a piece. They didn't just compress it. They used a similar chemical compound that's used for pulp, the pulp process. Okay. And that somehow, I have to read this because, they boil it in chemical mix similar to pulp and then compress it and heat it. Yeah, 80% reduction in size with 10 times the strength.
Wow. Was that the article that they said wood is now strong as steel?
Yes. Okay. It was that one. And I don't know, I didn't do any other research to see with the validity of it or not, but it sounds, if that's something that is legit, like, that's amazing.
Yeah, it will be.
I don't even, like, what would be the use for steel then after that? I feel like that's okay. Like, you know what I mean? Like, that seems pretty incredible, but Yeah, that's unfortunate you don't know anything about it.
Yeah.
But it's
there'd be a lot of testing that had to be done to make sure.
Well, that's what they said. They said they just, like, you know what I mean? I think they were just in the lab and they're like, hey, we did it! And they probably did like a 6-inch piece or something, right? Like, it's not nearly probably at commercial scale yet, which is why Japan said, I think it was 2040 they said or something. Like, it's a ways down the line, right? But, yeah, something like that. Like, the technology, I can't even imagine. Like, now we're pulling out, you think about the pulp process, we're pulling out lignin from the cellulose and we can create like cement similar type stuff using lignin, and we can create like there's all these different types of wood products that you can use, right? Like that the one I did with Dalabar was great. Oh yeah, the podcast I did with the Dalabar, I think it was episode 11 or something like that. But he brought in a little sample box of all the different wood products.
Awesome.
And using the, like, for example, what's it called? This crystalline cellulose.
Okay. Yeah.
Whatever it is, all that kind of stuff, right? And it's amazing the stuff that they can start to do with that, and they're just kind of breaching the iceberg, and they're just kind of figuring out what's going on with all that technology, because it's going to be, it's going to change the game big time.
Oh, exactly.
Well, something like CLT and that kind of stuff seems like it's already changed the game so much. What's going to happen next?
Yeah, for sure. Yeah. You know what? And there's a gentleman here in town. His name's Gary Channon, and Channon Hardwoods, and he's got a shop not too far from here. It's just a massive warehouse full of all types of wood. And he generally is dealing with more architectural stuff, not structural stuff. So, creates everything. Creates toboggans and mantles and tables and all kinds of things. Yeah, boardwalks, all kinds of stuff. Anyways, I was having a chat with him, and one thing I never knew about, but he was creating bearings and gears for oil and gas out of wood because they last longer than the new age stuff made out of plastics.
What?
Yeah.
How the hell does that work?
It's old style technology. That's what they used to use, and they went away from it. And then they've come back to it.
So, like, how long ago did they use that?
Oh, like 50 years ago or something.
Really?
Yeah.
Wood bearings.
Yeah.
So what do they do to the, like...
I'm not too sure. We didn't get into it too far, but I was just...
It's not like ball bearings then.
No.
It's like some other...
Yeah.
Yeah, okay.
Yeah.
Huh.
But yeah, because the friction on the new stuff destroys them very quickly.
Okay.
So they started going back to using wood.
I have no idea what that would look like.
No, me neither. But it was a pretty interesting conversation.
That's ridiculous.
Yeah.
I'm just trying to imagine what... So did they have to... I guess you're the wrong person to ask. You don't know, but do they have to? They must have to lubricate it still, and
Well, and using lignin.
Oh, okay.
Yeah. And
okay.
He'd be a great guy for you to have on.
Yeah, no kidding. That sounds cool. Huh. Wild. That's bananas.
Yeah, his knowledge is amazing when it comes to wood.
Oh yeah. Well, even I went to what was the award ceremony you guys had just recently?
Oh, the Prairie Wood Design Awards.
Yes, the Prairie Wood Design Awards. Yeah, I was there. And Norman from Work Wild invited me to come check it out, and looking at some of those buildings like that. Well, that one construction group got like 4 awards or something like that, right? They had the pop-up restaurant.
Yeah.
And, that was really, really cool to watch. Like they had 2 different pop-up restaurants, right?
Yeah.
So one of them was like, I don't even know. You explain it. I can't even, cause like one of them they used 2x4s and stuff, and they just kind of, I don't even know.
They made a lattice out of it.
Yeah, like a log cabin style.
Yeah.
But
and then the other one was kind of pieces, almost like puzzle pieces, but not put together in the traditional flat way. It was more
perpendicular. It was
perpendicular on each other. Yeah.
And then they had like a canvas over top to totally cover it. But it looked really, really cool.
Yeah.
I can't imagine how long it took for them to.
I'm not too sure how long it took them, but that's out of Manitoba. Those were out of Winnipeg.
Right.
So our project services Alberta, Manitoba, and Saskatchewan.
Oh, okay, yeah.
Because we call it the Prairie Wood Design Awards.
Yeah.
We give them an opportunity to be able to submit their projects.
And they took all the awards.
Took a bunch of them, yeah.
Yeah, though it was really cool because then they didn't use any fasteners or anything. It was all just like tongue and groove type deal, exactly. Right?
Yeah.
They're just and a canvas, I guess, on top, and that was it. Yeah. But the stuff they can do, like you guys redid the atrium, or not you guys, but someone did the atrium at the U of A, too. Yeah. And I haven't checked it out in person, but the pictures that were on there was incredible. Like it looked so cool, and that's got solar panels in the glass, and it's got I don't even know a bunch of different stuff. Oh, and the what was it? The Mosaic Center. That's like your guys' big one, right?
Yeah, that was one that we worked with. We don't do any like actual design work or anything like that. We help we help the owner or the designer themselves garner a bunch of information that they need.
Right.
And that was kind of that's the farthest northern building of that type that is net zero, LEED. I want to say LEED silver. As well as 3 petals out of the Living Building Challenge.
Okay.
It's got everything. Solar panels. He's got beehives out there.
Geothermal too, I think, right?
Yeah.
How does the geothermal work? How do you know?
That I don't know.
Yeah. Like I understand the concept, but I'm like, I would like to see the actual like mechanism to do this, right?
Yeah. I don't understand what goes on underground. I'm more of above ground.
You're a wood guy.
Yeah. But yeah, it's an amazing building, and amazing owners, amazing architects that were involved in that, engineers, everybody that was involved in that project. They put up an incredible building, and as well as that, it's not all wood. There's some steel in there as well. That attaches the 2 sides of the building together. That's what they needed, and that's what they went with. But it looks really very pleasing. You have the warmth of the wood. You got some black steel in there. They have glass in there. Some nice concrete floors as well. And it's just a beautiful, beautiful building.
I wonder, I just had a weird thought regarding, I was like, okay, so where do you steel? And I'm thinking about all the things you like. Do you ever think there'll be like you can make something for, like, make cars? Like maybe not the engine, but like make like the body out of it. Like I know the original Model T, I think, had hemp fenders, I think. So I don't see why you couldn't do something. And apparently it was really, really strong, and it kind of bounced a little bit, so you wouldn't dent as easy, wouldn't scratch as easy. So I wonder if you could do something similar, like with wood.
You can. I'm trying to remember his name, and unfortunately I can't. But his company's name is TTS.
Okay.
He's got a facility here in Edmonton as well, out in Drayton Valley. But he produces interior panels for cars that are made out of wood fiber.
That's cool. Yeah. How does that compare in weight? Do you know?
I don't.
It's plastic. It's probably a little heavier, I'm guessing. But
I would think so. But I don't know the comparison. But it was just something that's kind of come up that we talked about and such. And it'd be cool to see. Like now they got the aluminum Fords, right? It'd be interesting to see if you get a wood, a wood-bodied car at some point, to see how that works, right? And he supplies, like, it's not just like one-off supply. Like he supplies to Ford. He does, eh? Like he supplies to American automakers. Right. So it's like, it's already in the making. Oh yeah. That's so cool. Yeah. Like I can't even imagine where it's going to go next. Like with that, like I said, with that technology, right? Like we can remove it, turn it into its like basic building blocks, cellulose and crystalline cellulose and lignin and stuff, and the things we can do with that is ridiculous. Yeah, it's like basically breaking it down to like the atomic level and starting from scratch. It's like that's the next step, right? Yeah, exactly. No, it's bananas. Do you guys have any like resources for people that wanted to look into, like, say, building? Sure. Building something big with wood, they could look into to try and where they would start to do something like that? The first place to start is the Canadian Wood Council's website. Okay. So just Google Canadian Wood Council or CWC, go to the website there, and from there, there's a multiple of tabs with case studies that we've done on buildings, research papers that are there. You can there'll be links to mass timber buildings or tall wood buildings, as well as mid-rise buildings, which is 6 stories and under. So more of the light frame construction side. Yeah. So there's tons of information there. Contact us directly. Nice. As well. So there's a ton of resources there. I'm excited to see, I hope it explodes, right? I hope we start seeing these tall wood buildings and medium-sized wood buildings all over the place. Like, is there any current ones that are going up, like multiple story ones, like near, like, an Edmonton area or Alberta? Yeah, sure. So, actually right now, on 149th Street and Stony Plain Road, there's a project that was kind of defunct for a while called Glenora Towers. Okay. A group came in and bought that. Now they're finishing off the residential tower, which is a very large residential tower. It's all in concrete, but right next to it, they're in the process. They're just putting it up right now. A 3-story office building. Oh, okay. That is all wood. That's awesome. Glulam post and beam construction, and then glulam floor systems. Sweet. So they're also in the midst of doing a 6-story residential building somewhere downtown called CX. Okay. I know people may have seen the pop-up bus driving around downtown called CX. That's going to be a hybrid building. I believe it's a steel frame structure, and then they'll be using a mass timber, so a glulam or CLT floor system in there as well. So that's going on right now here in Edmonton. We do know there was the second round of the EOI that went out. There was, I think, 3 projects out of Alberta that were submitted to it, and it sounds like one was shortlisted. Oh, okay. So we may see a tall building, a minimum of 10 stories in Alberta in the very near future. So.
That's awesome. I'm looking forward to it.
So am I.
That's going to be really cool.
It's been 10 years, coming up 10 years with this program, and it's been a slow moving process. But looking back, it's like, man, 10 years ago, we were doing 3-story, 4-story buildings. But going through the process, it seems like it has taken a really, really long time. But looking back now, that if we do a really tall building and look back and say, wow, it actually hasn't taken that long. But even, Ritchie Market is another building that's kind of gone up in the last year or so. A 2-story little office building out in the Ritchie. And I'm sure people that are listening to this are, familiar with Transcend Coffee and Acme Meats, so that's where they are now.
Okay.
And a nice little wood building there, and the new Mech downtown. Their whole roof system was CLT.
Right. Yeah. That's a large 2-story building. It's like what are they, like 12-foot ceilings or something like that? Yeah. So that's a beautiful building actually. Yeah.
So the walls aren't wood, but the roof is, and actually the change rooms and the interior build out is actually all CLT in there. So if people are interested in what this thing looks like, if they're in Mech, that's what it is.
That's what it is. Yeah. That's really cool.
Yeah.
Awesome.
So, lots going on. And
no, I just hope we see more and more of it as time goes on. I think we will. It only makes sense, right?
Yeah, exactly.
People love the look of it, and it seems like the engineering side of it is we figured it out. So
for sure.
That's awesome.
Sure.
Cool. You got any kind of final thoughts or anything you want to put out there for people to say, or you pretty much done it?
Pretty much done. we do have a design seminar coming up in June on the 5th and 6th. 5th here in Edmonton, the 6th down in Calgary. We try to run them the same people speaking. We have Russell Acton, who is the architect of the Brock Commons.
Oh, okay.
He's coming to do an hour presentation on that project, as well as some of his upcoming projects.
Nice.
We have another gentleman, Andre Ryu, with an acoustics specialist, who's going to talk about acoustics in these types of buildings, because acoustics is an issue when it comes to mass wood buildings.
Okay.
We need concrete floor. We need some acoustic matting in there as well to deaden that sound a little bit, because
it just carries with the wood.
Exactly.
Okay.
So he's going to come and talk about that and try to give some solutions and some information to everybody.
Sweet.
And we also have one of our representatives from the Canadian Wood Council, Ineke Van Zeeland. She's going to come and talk about what's happening at the building code level and what we hope to see in 2020 with the new building code, and try to give some more information and some ammunition maybe for the designers to go forward. So
nice. Well, it's good to see that's moving forward that quickly, right?
Yeah.
That's awesome.
Yeah.
Good stuff.
Exactly. Excellent.
Well, I think we covered a lot. That's 46 minutes in. So.
Oh, wow.
Yeah, I know, right?
Time goes fast.
You feel like you've been sitting for 20 minutes. We're like, no. It's been a while.
Yeah, I'm not gonna lie to you. I'm thinking, how are we going to fill an hour with me talking? I don't really have that much to say, but it goes fast.
It's when you know what you're talking about, it just kind of comes, right? Yeah. It's all good. So perfect. Well, thanks a lot for coming on, man. This is awesome.
Thanks, man.
Appreciate it. Thanks a lot for listening, guys. Make sure to check out Woodworks program. It's really, really cool. And, next time you have the option, go for wood, use it. Why not? It's beautiful. It's most sustainable. You're helping out the planet, and it looks cool. Thanks for listening, guys. And we will, check you out next time. See ya. And if anyone wants to get a hold of me, you can reach out to yourforestpodcast@gmail.com, and I will get back to you. I'm also on Instagram, Twitter, Facebook, all that stuff, LinkedIn. What else? Rate and review. Appreciate it. See ya.